Hello, this is Ms. DB, and in this lesson we're going to learn about how to factor polynomials. This is from Chapter 6, Section 4, and our objectives are to use the factor theorem to determine factors of a polynomial and also to factor the sum and difference of two cubes. We'll be factoring several different ways in this lesson. All right, if you have a number divided by any of its factors, the remainder is 0. Like if you had 12 divided by 3, you would get 4, remainder 0. So we're going to remember that and use that fact to check if a polynomial is divided by any of its factors, the remainder will be 0. So we can use something called the remainder theorem, which says that if a polynomial is divided by x minus a, the remainder is the value of the function at a. And we looked at this a little bit when we did some synthetic division at the end of that section. So if x minus a is a factor of p of x, then the remainder, p of a, will equal 0. Let's see how that's going to work. So there's the theorem written out in a nice little box. And the example is if you have a polynomial and p of 1 equals 0, then that means that x minus 1 is a factor of the polynomial, which was x squared minus 1. All right, so let's check and see whether the given binomial is a factor of the given polynomial, p of x. So in A, the first parentheses is the possible factor, that binomial that we want to see if that's a factor, and the second parentheses is the polynomial p of x that we want to see if that would factor to have x plus 1 as one of its factors. So we could, try to factor it, but some of them, like in B, we can't factor in normal methods. So here's what you do. We want to take the opposite sign of not the x, but the number after it. So p of negative 1. And then we're going to do synthetic substitution. So remember, for synthetic substitution, you put the number up here with a little box around it. And then these are the coefficients of the term. So we have, of the polynomial p of x. So we have 1x squared, so the 1, minus 3x, so there's the minus 3, plus 1, and there's the 1. And we leave a space here and then draw a bar. Then we bring the 1 down. Do I have my pen? Bring the 1 down. And then we take 1 times negative 1, and that's negative 1, and we write the negative 1 under the next number, the negative 3. And then we add those two together, and negative 3 plus negative 1 is negative 4. And then we multiply negative 4 times negative 1, and we put that answer, which is 4, under the 1, and we add again, and we get 5. That's the remainder. If it's not 0, then x plus 1 is not a factor of our polynomial x squared minus 3x plus 1. So x plus 1 does not work. Okay, let's try B. So again, we're going to use the opposite of the number, the constant in the binomial. So we start with negative 2 for our synthetic division setup. And then we need 3x squared plus 6. There's our next one. Now there is no x squared term, so we would use a 0 as a placeholder there. And then the minus 5, and then the minus 10. Negative 5, negative 10. Then leave a space and draw a bar, and then the first step is to drop down the 3. And then we start multiplying. 3 times negative 2 is negative 6, and that answer goes here. And then we add those together. 6 plus negative 6 is 0. And then we multiply back. 0 times negative 2 is 0. And then 0 goes underneath the other 0, and we add, and we get 0. And then 0 times negative 2 is another 0, and we put that under the negative 5, and we add, and we get negative 5. And then negative 5 times negative 2 is a positive 10, so we put that underneath the negative 10, and we add, and this time we get 0 for the remainder, and that means that x plus 2 is a factor of the polynomial. So the answer is yes, because we got a remainder of 0. All right, this is just another example using the same method. So to check if x plus 2 is a factor, we do synthetic division, use the opposite sign of the plus 2, so use negative 2, and then complete your synthetic division by bringing down the 4. 4 times negative 2 is negative 8. Negative 2 plus negative 8 is negative 10. Then you multiply and get negative 10 times negative 2 is 20. So 25. That is not 0. If the remainder is not 0, then this is not a factor. For B, this is a long one. Make sure that this polynomial is in standard form and then it's not missing any terms. Looks good. So this time, look, where did they get the 2 from? We can't use a binomial that has a number in front of an x. So what you can do is factor out a 3, or divide each of these terms by 3, which leaves us with x minus 2. And then the opposite of minus 2 is a positive 2. And then we complete our, and you also have to divide each of these by 3. So if you divide both the polynomial and the binomial by 3, that results in 3 divided by 3 is 1. Negative 6 divided by 3 is 2. 6 divided by 3 is 2. 3 divided by 3 is 1. And negative 30 divided by 3 is negative 10. So we divided both the polynomial and the binomial by 3. And then we have a smaller problem to work with here. So we drop down the 1, and then we do our synthetic division. 2 times 1 is 2. When we add that, we get 0. 0 times 2 is 0. When we add that, we get 2. 2 times 2 is 4. 1 times 1 plus 4 is 5. 5 times 2 is 10. And negative 10 plus 10 is 0. So this is a factor because we got a 0 as a remainder. These are the problems from your worksheet. You're going to be doing the same thing. Let's just pick one to do. Let's do number 3. And none of these you'll have to divide by. You'll see they're all just x. There's no 3x or anything. So let's do number 3. So again, we have to take the opposite sign. So that'd be 6. And then the coefficients of the polynomial would be negative 2, 15, negative 18. Leave a space. And now I'm going to drop down the negative 2, and then I start multiplying. So negative 2 times 6 is negative 12. And then I add these. 15 plus negative 12 is 3. And then I multiply. 3 times 6 is 18. And negative 18 plus 18 is 0. So our remainder is 0. So you would say yes, and then you could say that the remainder is 0. So that's it for those, determining whether a binomial is a factor of the polynomial. All right, so we've done plenty of factoring in the last chapter. We did, like if you had x squared plus 6x plus 5, we could factor that with like the opposite of FOIL. We would say we need an x and an x, and the factors of 5 that would add together to get 6 would be 1 and 5, so I put plus 1 plus 5. That's one way to factor when we have a quadratic. But we also learned a few other methods in Algebra 1 and in Chapter 5 that is applicable for this chapter. Because if you add more terms here for this polynomial, you can't do this binomial factoring, this trinomial factoring anymore. We have to have some other methods. So here's one way, factoring by grouping. Factoring by grouping, this is a little tricky because of the minus sign here. It's basically going to be putting these into 2 different sets of parentheses. The first 2 and then the last 2, and putting a plus sign between them. So the minus, it's easier if it's just a plus, but the minus here means that we have to like shove this over and call this negative 25x. All right, then what you do is you say what's common in both of the terms in the first parentheses. And let's see, there's an x and an x. Well, actually, there's an x squared in both. So then you'd put the x squared in front, and you'd say, okay, what's left if I factor out an x squared, or if I divide each term by x squared? So x cubed divided by x squared is x. There's just one x left. And then if I take x squared divided by x squared, that's 1. It's not 0, it's 1. And you can check by foiling back or doing the distributive property. You'd have x squared times x is x cubed, and then x squared times -1 would be minus x squared. So that works. Now in the second set of parentheses, let's see, this one has an x, but the other one doesn't. So there's no x in both, but there's a 25 in both. So we put the 25, and we would get negative x plus 1, not 0, 1. Now these are very close to each other, but they're not exactly the same, and we want them to be exactly the same. So instead of factoring out a 25, let's factor out a negative 25, because negative 25x divided by negative 25, that would be 1x. So that's just x now. And then 25, the other one, divided by negative 25, that's negative 1. So let me erase this and put a negative there. All right, so now x minus 1, x minus 1. Now they're exactly the same. So I can now factor out the x minus 1. I write that in front. And if I factored an x minus 1 from this term, I would have an x squared. And if I factored a x minus 1 from this term, I would have plus negative 25, or I can just write minus 25. So now I have factored by grouping. Now I look at each of these factors and I say, can I factor this anymore? So x minus 1 obviously can't be factored anymore, but x squared minus 25, now that's something that we did. Let me just rewrite x minus 1. We did x squared minus 25 before. That's x minus 5, x plus 5. Let's double check with FOIL. We would have x times x is x squared. Yep. This would be 5x, and this would be minus 5x, so we'd have no x term, just like we didn't. And then negative 5 times 5 is negative 25. So our final answer then, factoring by grouping, would be x minus 1 times x minus 5 times x plus 5. Now this was one of the more complicated ones, so let's look at some that are not as complicated. And we're not going to do that one. Okay, let's look at this one. This one again, factoring by grouping, has a minus sign. So I'm going to put the negative with the 9 and change this to a plus. All right, so now we have to write, we'll write our factors as x cubed minus 2x squared plus negative 9x plus 18. Now we look for what's common in both pairs of factors. In the first one, we could factor an x squared out of both. And when we do that, we would be left with x minus 2. In the second one, we have a negative 9 in both. So I'll factor a negative 9 out. Now you could factor just 9 out, but then you'll see again that your two sets of parentheses are supposed to match, and they won't unless you factor out the negative 9. So now I have x minus 2 and x minus 2. Those are the same thing. Those are common binomials. So put that in one set of parentheses, and then really it's just what's left will go in the other. So these will go here, and this goes here. And that's it. Oh, nope, now we got to check. X squared minus 9. X squared minus 9 can be factored as x minus 3, x plus 3. Now we're done. So this was, again, a little bit longer one. Let's see, on this example, it's a plus sign. Plus signs are generally going to be a little bit simpler for factoring. So you'll put your parentheses around the first two terms and around the last two terms. We won't have to worry about the negatives this time. Then we look for what's common in each set of parentheses. 2x cubed plus x squared, there's an x squared in common. And when we factor an x squared out, we would have 2x plus 1. And in this one, we would have, there's a 4 in both, so we would factor out the 4. You'll see that this matches this, which is what we want. That goes in the first parentheses. And in the second parentheses, you get what's left. Now, x squared plus 4 is not factorable. That is not difference of squares. So you just write it and leave it. There's no way to factor that farther. That's your answer. 2x plus 1 times x squared plus 4. And these are the problems from your worksheet. You can see number 5 is already started and almost ready to be finished. You'll see this is common in both. So that goes in the first one. And then you'll check and see if x squared minus 4 can be factored. If it's x squared minus a perfect square, then it can be factored farther. So you could do x minus 2, x plus 2 for that part. Don't forget to rewrite the x minus 3. Let's look at number 8 with the minus sign. It's a little trickier with the minus. So this would be a plus a negative 16x minus 32. So we'd have x cubed plus 2x squared plus negative 16x minus 32. So in the first set of parentheses, there's an x squared in both. And when I divide or factor out an x squared, I'd have x plus 2x squared divided by x squared is 2. Remember, even if you had x squared over x squared, when you factor, you'd have a 1 there, not a 0. And then I've learned from doing these last few that I should probably factor out a negative 16, not a positive, because I want this parentheses to be same as this one. So negative 16x divided by negative 16 is 1x, and negative 32 divided by negative 16 is plus 2. Now we have the same parentheses, same factor, same binomial, and x squared minus 16, if it's a perfect square minus perfect square, that can be factored as x minus 4, x plus 4. And you can check by foiling, but that one should work just fine. All right, let's see what we have next. Just as we have a special rule for factoring the difference of two squares, there are also special rules for factoring the difference or sum of two cubes. So if you have a cube plus a cube, then you can rewrite it using these special methods. And it works also for a cubed minus b cubed. You will see that some of the signs are different. Let's look at how we do this. First, we have to figure out, this doesn't look like a cube, but there is common factors that we can factor out. Always check for common factors. In this case, there's a 4x in both of those terms, so we factor out the 4x, and we would get 4x times parentheses x cubed plus 27. Now you can see it does look like a perfect cube plus a perfect cube. So this is going to be the sum of cubes. And here's the rule over here. And you should, copy these or print them and hang them up or something. So it's going to be a cubed plus b cubed is equal to a plus b, this is a times sign, not a x, times a squared minus ab plus b squared. So we're going to use this rule, except RA is going to be x, because that's the number that is being cubed, or the term, the variable. And then our b is the 3, because 3 cubed is what's equal to 27. So wherever I saw for the rule a cubed plus b cubed, the a is going to be replaced with x, and the b is going to be replaced with 3. The 4x does have to get written out front. So far we have 4x, and then we have a plus b, that's there, and then a squared, that's going to be x squared, minus x times 3, but we write that as 3x, and then plus b squared, which will be 9. So this is all the same thing except simplified slightly. The 3 squared changed to 9, the negative x times 3 changes to minus 3x, and then that's it. We look at then the trinomial x squared minus 3x plus 9, and we decide whether or not we can factor that. Sometimes you can, but not in this case. But you do check and see, because sometimes you can factor a little bit more. All right, in this one, check and see if there's a common factor, but there isn't. So then we think about this, or we rewrite it as two things being cubed minus each other. So 125 is the same as 5 cubed, and d cubed, of course, is d cubed. So you write it as 5d cubed minus 2 cubed, because 2 cubed is 8. So that means that a in our difference of 2 cubes is going to be 5d, and our b is going to be 2. So we write the rule. Here's the rule. a minus b. Now a is 5d, b is 2, so we have 5d minus 2. And then a squared, that's 5, it's not, the answer is not 5d squared, it's 5d, the whole thing squared. So 5d squared would be 5 squared is 25, d squared is d squared. Plus a times b, so that's 5a, or 5d times 2, and you multiply the 5 times 2 and get 10d. And then plus b squared, and b is 2, so 2 squared is 4. And then we check to see if we can factor anymore. This one is a little bit simpler. We have 2 for a and z squared for b, and we just plug them into the rule. This one's a sum of cubes, not a difference. And then this one's a little bit trickier because you have to factor first. You have to factor out the common factor of 2x squared. That number, that factor, will stay part of the final answer, but it's not part of the rule for difference of cubes. So the difference of cubes part just gets, you plug in that in this case a is going to equal x and b is going to equal 2, and you plug those in for the a's and b's in the rule, and then you will have your final answer again will have the 2x squared in front of it. All right, here's some of the problems from your worksheet. Let's look at number 11. This is the sum of 2 cubes, so we're going to use this rule, and a will be equal to y, and b will be equal to 3, because 27 can be rewritten as 3 cubed. And then all you do is you write this part, but wherever you see a, you'll put y, and wherever you see a b, you'll put 3. And then you'll just, let's see, this would be a times, that'd be y times 3, or you can write that as 3y, plus b cubed. B is 3, so b cubed is 9. That's all there is to it. It's just plugging them into the formula.